Okay, come to the mixed data type, where we can apply this mixed data type. In the put w get w are applied for the only integer interaction with the integer interaction to the files, and put c get c character interaction with the file. Whenever mixed data types are there, okay, then we can follow the following four type of functions. First two functions, fprintf. Second one is the fscanf. Okay, one one function, it can print information into the file. Okay, what type of information is there we want to store in the file? That information must be with the help of fprintf only, that will stores the information into the file by using fprintf. Next, from the file, we want to access the mixed data type from the file by using scanf. We are scanning information from the file. So, information from the file to the current program. Fprintf, we are passing information from the current program to the file program. That is fprintf. We are printing information onto the file. Next, fscanf, we are copying data from the file program to the current program. So, fprintf and fscanf we can study, and these two these two functions are divided into three parts. First one is the uh, okay, okay. First one is, what is the first part of this function? That is a file pointer. File pointer. Okay. Next one. First one is a file pointer in the two functions. Next one is control string. In both functions, you can find control string. What is control string? Okay. Next, what are the variables we have to pass into the file? Next, same in the file also. Fscanf also, we are using variables. Okay, for suppose, let us take one example. Let us take one example. Okay, so pointer fp. Next, control string is always within the double quotation, like this. Like this only, we can use the control string variable. Okay, in scanf we are using at the rate ampersand. Scanf we are using ampersand, and printf we are using no need of ampersand. So that is the difference between fscanf and fprintf. Let us go one program. Okay, then we are able to understand the total meaning of fprintf and fscanf. Okay, okay. Let us examine the two functions. One is fprintf, fscanf. First, let us verify fprintf. Sorry, fprintf. So now we are writing program for fprintf. Next, that fprintf contains three parts. First one is the file pointer. Next one, according to the data, we have to give format specifiers. Okay, it is not. It is only example. Next, next part is the variables. Variables. That way, you have to give the um, syntax for f. Next, fscanf. Fscanf. Okay, first parameter is pointer. Next parameter, here also have to give format specifier. According to the order of the information, have to give format specifier. According to order of the information, have to give variable names um, along with the ampersand. Let us verify. Fprintf is used to store our mixed data information to the file. Fscanf, it is provide the accessibility. We are getting information from the file which is mixed information. So that is the difference. Okay, let us verify one program here. Okay, actually these both functions are applicable for the mixed data type. Here mixed data type is a structure information. So first we have to declare structure. Okay, it is very simple. Okay, what are the fields are there in structure? Structure student, name of the student. Okay, name of the student. Next, roll number. Next, okay, student average. In that way, we can declare fields of the structure. Or next, structure must ends with the semicolon. Next, start main of the program. Okay, first to declare structure variable. And, okay, you can declare any type of structure variable. Okay, here I declared x variable. First, uh, let us store the student information with the student information locally. Then we can pass this information into the file. So that's why printf enter the student information, student information, student information. Scanf, scanf. What is the first field of the? Okay, initially have to load each and every member of the structure. Have to load local with the local variables. Okay, what is the first field? String field. Next field is integer. Next field is the floating type. Next, what is the variable? Ampersand. What is the variable? X is the variable. X dot name. Okay. Next, ampersand. X dot roll number. Next, ampersand. X dot average. Now we loaded the structure student mm, fields. Then we can pass all the structure student fields into the file. How we can pass all the fields as a different types into the file by using fprintf. Fprintf. What is the okay? Before that, you have to declare the file also. File pointer fp. Okay. Now we can okay here I have to open one of the file fopen f fopen. Okay, you can open any one of the available files. For before you have to give the program, you have to give the uh, exact file name. Here there are so many file names are, then you can give one file name. Okay, file one I will go now I have into the file one.c. Okay, dot in what mode you have to write? You have to open write mode. Why? Because now we are going to store the total mixed data information to that file. Now fp is the file1.c file. fp is the file1.c file. Okay, that is opened as a write mode. So that's why this fp refers this file information. Now if we pass any information into that file, okay, that is a mixed format or anything that is reflect into that file. First one, what is the first format? String format. Next format is the integer format. Next format is float format. Okay, what are the variables? What are the variables? These are the, okay, these are the variables. X dot name. Okay, next one, X dot roll number. Next, X dot average. Like that, we can store this entire this mixed information into this file. Uh, After storing this information, we can open the file1.c and we can observe the modifications, and we can observe the data which is available in file1.c. Okay, after storing that information, close f close f close fp f close f. Let us execute this program. Let us execute this program and we can observe the information. Okay, what is the function? Fprint fprint 1.c. Okay, let us execute this program. Okay, so files must be executed with the initial declaration of hash include stdio.h. Okay, then only the files are going to execute. Then you cannot find no errors. Okay, first enter the student information. What is the first student information here? Fields are name, roll number, average. In that order, you have to enter. Okay. Uh, Akhil is the name. Sorry. Okay. Next roll number. Next percentage. Okay. Just we are passing the total given information to the file, but we are not going to print in this program. After we can give the read operation also. Let us verify the exact file. In the um, given files, our file name is file1.c. The file1.c means it is available. Okay, that information is loaded here. Like that, by using fprintf, okay, it is the output of this program. By using this fprintf, we can load mixed data format information into the file. Okay, so it is very clear to pass the information to the file. Next, we can pass at the same term. Now we can apply fscanf also. The following fscanf is accessing data from one of the file, and we can print the data into the output stream. Okay, then we are closed the file. File underscore one file is closed here. Now we can open the same file fp equal to fopen. What is the previous file name? File underscore 1.c. Next, have to open the same file as a read in the read mode. Then it is uh, then we can access the information. Okay, so from that file we have to access the all information from that file. Now we can apply fscanf from what is the file pointer. fp is the file pointer. What is the order? In the information is available in the file in this order. Okay, in this order only the information is available in the file. We can apply the same order here. We can apply the same order, but here we have to use ampersand 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 symbols. Why? Because we are accessing the data from outside of this program. Outside of this program means from the files only we are accessing. Then we can print the each and every variable in the output screen. Then printf. Okay, what is the first format? Name. Next format is uh, roll number. Next format is the age. Okay, so in that way we can apply the same method to print here also. Then you can close the again f close f and close it. Okay, so it will print um, okay, first part is how we are giving new information to the file. Okay, the information is about student information. The student information, especially, that is the structure information. The structure information is the collection of different items. So by using structure only, so that's why we are using fprintf. Okay, mixed information we are going to store in the file. In the second, okay, then we are closing the file. Second time we are opening the same file with the read mode. Okay, then we are accessing the same file content in the same order. We are printing in the same manner. Then finally we are closing the program. Okay, so now we can uh, perform that execution also. Okay, student information. Okay, we are given information, and from the system also we are getting the information. Again, have to verify the file also. What is our file? File1.c. The file1.c. Okay, you can see here also. Okay, okay. So it is the updated information. In that way, we can read the file, and we can write the file. We can read the file whenever it is the file contains mixed type. So that is the usage of fscanf and fprintf. These functions especially used in the file and mixed data type handling, especially in the structure type structure. Okay, let us go to the fread and fwrite operations also. So it is come to the first one. The syntax and format is very different, but it is very simple compared to fprintf and fscanf. Okay, here first come to the these two functions are very uh, different functions compared to the previous functions. What are the previous functions? Fprintf, fscanf, and now these two functions, fwrite and fread. These two functions are called as binary functions, binary file operations. Binary file operations means entire our information here in this output. In this output, we are getting the output in normal format. Okay, Kumar 34 is the roll number. 60.78900 is the floating point number. Okay, so all information is very clear information. So files are available in two types. One is the character file type. Next one is the character stream. Next one is the byte stream. In the character file stream, exact information is stored, exact information is displayed, but it occupies more memory space. So we can find one advantage, one disadvantage. One advantage is entire information is stored according to we are providing. Okay, but it occupies more space in the memory location. Next, come to these two functions, fwrite and fread. These two functions called as binary functions. Binary functions means the files can store our information in binary format. So binary format is a special type. Binary means binary. Every information is converting into binary type. In that binary type only the information is stored in the file. Okay, sometimes only we are getting clarity about the data whenever we are opening the file. Yeah, almost all the time the total information is converting into binary equivalent format. The binary equivalent format is stored in our file system. But it is very simple. It occupies very less amount of the size. And this operation is also very simple. Okay, let us check what are the parts of this function. Okay, let us verify here. Three parts are there. First part, variable part. Next part is the size of the variable. Totally four parts. Size of the variable. Second, okay. Third part is the number of times. Number of times. Here, one constant is given, that is one. Okay. Next one, file pointer. Okay, in fwrite or fread, you have to remember this sequence. Okay, first part is variable. Especially we are applying this part in any type of information. Either it is variable, simple variable, or array variable, structure array variable. Any type of variable is applicable. So declare one variable, either structure variable, have to give ampersand, comma, size of that variable. Okay, comma, one, comma, file pointer, where you have to access the file, where you have to write the file. In that way, a file pointer is one of the file pointer is there, which is already open a particular file. So that is the related. So in that way, but it is very simple to operate. But one more point, it can stores the information in binary format. Okay, we cannot read that information, but by using this read and write operations only, system able to convert entire information into binary to analog. So let us verify syntax and the formats of the fwrite. But both are working just like fprintf, fscanf, but it is the different representation. Purpose is same. Okay, let us go to the program. Here I will take student structure. Okay, first up to here I will copy. Up to here I will. Okay. Now, what is the title of this program? Fwrite. Fwrite. Okay, what is the fwrite? Ampersand variable. Any type of variable according to our program. Here, what is our variable? Student structure. Student is the variable. Okay, next size of that variable. Size of that variable, and have to give one. Next, file pointer. Okay. Next, then we can discuss about read. F read. Same format we can apply. Ampersand variable and size of variable one and file point. Let us verify practically these concepts. First, we declare file pointer. Then file pointer have to open one of the file function. Okay. First, you have to use the write. For the write operation, you can give new file name also. You can give any new file name. Why? Because that file is not available. So that's why that file is going to create. Okay. Now, um, first, we have to load structure information to the local variables. Then we can store the total information into the. Okay. I have to declare structure variables also. Struct student again x. Okay. Printf enter the student info scanf percentage s percentage d percentage f. What is the first variable? Ampersand capital X dot name. Next ampersand capital X dot roll number. Next ampersand capital X dot average. Okay. Okay. First we are loaded the total structure information. Then we can apply fwrite. Fwrite. What is the variable here? What is the variable here? X is the variable. What is the X variable? Student. Student variable. Next size of, it's very simple to use. Size of, what is the variable? X. Next we have to use 1. Next, what is the file pointer? F2. F. So in that way you can write the total information into the file. Okay, then you can close the file. F close of fp. Okay. Okay, in that way you can finish fwrite operation. Fwrite. Fwrite 1 dots. Okay, here also we have to declare. Yeah. Okay, no error. Again have to enter some student information. Okay, that information is stored in a particular, what is the new file here? 4a dots. Okay, you can go and verify 4a dots. So this 4a dots is created, but that is not visible to us. Okay, let us check what is the information is required. Okay, okay, this it is the binary format. Okay, only Kumar is only visible clearly. Remaining all is a different symbols. So that is a binary file format. Then we can apply the read operation. Then it is very clear. The binary information is also loaded into our program. Now we can apply the fread. For that purpose, again, you have to open the file. Open. Okay, what is the file name? Okay, it is the file name. In what mode you have to open? Read mode. Read mode. Then okay, then have to use f read function. Read function. Okay, what is the local variable name? Capital X, comma. What is the local variable size? Size of the capital X, comma 1, comma fp. So this entire fp, fp contains some information that is loaded into x variable. So fp contains structure information that is loaded into local variable of x. Then we can print the information. Printf. What is the first information of x? Name. Next roll number. Next float type. Okay. So in that way we can print the total information. Roll number. Okay. Please, all of you, our session is going to close within 1 minute. If it is closed, you can re-log in again. X dot dot then we can close the braces. Finally, you have to close file also. F close fp. Then you can compare. No errors. Okay. Uh, okay. So time's up. Please, all of you re-log in. Okay. Let us execute this program. So just compile. Okay, what is this program? First, we can load the student information, student structure information. Okay, yes, X always the student structure information. Okay, in write total instead of each and every format specifier, we are passing only one student structure variable and ampersand x and size of the x. What is x? Student structure variable. Next one. Okay, it is a constant number of times we are passing the information into total this information into the fp file. So one stands for the number of times we are copying. Okay, next time in that way we are passing the information, we are closing the same file, then we can open the same file in read mode. Read mode means it provides only accessing the data from file to the current running program. Then entire information. Okay, what we are assigning the total information to the structure variable x. Next, what is the size assigned to the data? Size of the x. Next, how many copies we are accessing? Only one copy. From where we are accessing? From fp. What is fp? 4as.c is the file. That file is already open in a read mode. Entire that information contained in fp. From that file, we are copying the information into x. And how many? What is the size allocated? Size of the depends on the size of the x. Next, how we can print the information according to the order of the data available in the file. So first information in the file x, name of the student, roll number, and average. Let us verify this program execution. No errors. Okay, first you have to store or give the student information. Okay, so the information is printed. So name, roll number, and average. Then we can verify the AA file also. Where AA file? Here we can find AA file. Here AA file. So some this information is not clear. Why? Because the total information is stored in binary format. In this case, in this fprintf and fscanf, it can store our information in character format. But fread and fwrite, fread can access the binary information from the file. Fwrite can store the entire information to the in the format of binary, and it will store in the particular file. So that is the meaning, and that is the mechanism of fread and fwrite. Okay. Next, uh, uh, it is a matter about mixed data type functions. Okay, in this mixed data type functions, we completed 4 functions. Okay, first one is the character type functions. Next one is the character stream. Next one is the byte stream functions. Byte stream means binary format information for reading for fprintf, scanf, fwrite, fread. Okay, these functions very important for the exam point of view. Okay, next, come to the last concept in the file. This is the last concept in the file, that is a random access. Okay, what is the opposite term of random access? Sequential access. That is the opposite term of the random access. Okay, what is sequential access? For suppose if you take one tape record, okay, nowadays we are not using a tape record or cassette. If you take example as a tape record cassette, okay, you can find reel. Okay, all songs all songs that are stored in that tape in a sequential manner. First song, second song, and the last song. How we can listen that songs sequential way. After first song, we are going to second song to third song. In that way, we can go to the last song. So that is a sequential access. Sequential access songs from the tape tape cassette. So that is called as sequential access. So in real time also we are so many times we are using sequential access only. But nowadays we are using random access files. Okay, best example of the random access files. If you open DVD, okay, total information is opened, and what type of information you need directly you can select some information. Directly you can play a particular song. So that is a random access files. So here also random access files, the type of all facilities are provided here also by using some of the functions. Now that concept is called random access files. So here also we are following the same mechanism, but here we are using only data files. Okay, more than that we are not going to practice anything here. Just we are practicing only files that contains data, either it is a character stream data or binary stream data. Now let us check what are the random access files. Okay, in this random access files, it's very important for the final exam. Okay, first function is ftell. Second one is the rewind. Third one is the FC. Today we will finish only first two functions. Okay, next class we can verify fseek and with so more examples. So today it is not possible to complete all the three functions. Why? Because fseek is a very big function. Ftell and rewind is very simple function. Okay, let us discuss about the ftell function. In the program directly we can discuss about the ftell. Okay, ftell of file pointer. Ftell of the file pointer. Okay, actually ftell of the file pointer. Okay, if you take one file, the file contains 1 to 10 lines. Just assume in that files uh, uh, in our reading, we can read first line, second line, and sequentially we come to the bottom of the line also. So currently we are reading suppose eighth line or fifth line or last line. So that is the position of reading line, reading of a line. So the same time, ftell also telling the position of the file pointer. Okay, where it is available, where it is located, means where the current pointer file pointer is located location is given by ftell. Okay, initially all file pointers at starting level. After completion of all each and every character, it goes to the final and bottom of the line. So that is the ftell function. Let us verify this program. Hash is a okay. We discuss these two functions and we can close the session. Okay, hash hash include ao.h and int main file. Just open one file pointer and fp equal to f open f open, read, okay, any you can have to give any one of the available existing file, that is file underscore file underscore one dot c, have to open as a read mode. Why? Because you have to find the location of the point. Okay, next you have to uh, maintain one character to print the entire information. Okay, while, okay, before accessing the data, let us check the initial location of the file also. Int n. Okay, here n equal to ftell of fp. Okay, so here what is the fun? Already file is opened as a read mode. Next, what is the file pointer? Definitely that is at the starting line of the starting line, means zero location. Ftell gives the answer as a zero. Why? Because the file is not, the file is ready to start, so that's why the location is zero. Okay, so then if you print n here, that will print zero. Print the location. Location is percentage d n. Then we can print the total information in the file. Equal to get c f equal to end of the file. Next, have to print each and every character. Just for example, it is very useful to understand the total file of this function. So that's why I am going to give this. Next, close fp. Then, okay, what is the file function here? Ftell one dot c. Okay, okay. Here n equal to ftell fp. Here it is the initial stage. Just we are open the file. Next we are finding the file location. Almost it is at the initial location of the file. Initial location of the file means zero. Okay, then we are printing the location. Then we are printing the total information in the file. Okay, the location is zero. Why? Because we are run one particular function ftell. Ftell. Okay, already where is the location? That is at the starting location. So that's why that is zero. So next remaining information in the file is print. Then here also we can print the same n equal to ftell of fp. Why? Because, okay, enter this instruction, enter this instruction. Okay, enter this instruction will print each and every character. Means it, the file pointer moving from one character to another character. So at this location, it comes to the end of the file. So it will print end of the line number, end of the character number, or end of the maximum number of the file will be printed here. Then again you have to print, uh, last location of the file is percentage. Why? Because where it is located in the last line of the program. So that's why. So that's why n will be printed last line of the program. Okay, here it's very clear to understand about F10. Okay. What is the first? The location is 0. That is at the file pointer is located initially before reading anything. So that's why that is at the 0. From 0th character to all characters are readed. Next, finally, where it is, the file pointer moved to the bottom of the file. Bottom of the file is after at the 67.78, that number is given, that number is there. After that only we can find the end of the line, end of the file. So the location of the last location of the file is 18. So now we can see the movement of the file pointer, that is moving from first character to last character of the file, means that is the end of the file. Okay, we are given one instruction, the file pointer moving from starting character to end of the file, end of the file. So but our output um, here, the ftell give the binary location of the file binary, so that's why that will give the one of the value information. So that is the meaning of ftell usage of the ftell. Next, come to one more function. I will close with this function. Okay, that is rewind. What is rewind? That is very simple. Now we are listening eighth song out of 10. Okay, rewind means, what is rewinding? If you press rewinding, that will go to the starting of the song. Okay, if you press rewind, that will starting from first song onwards, that will be played. So the same thing is repeated here. Same thing is repeated. Next, okay, here what is the file point location? That is at the last line. Okay, if you now we know it is the last line of the file. Next, if here we apply rewind of fp, then fp is go to the first line of the page. First line of the page. From that location, we can print. We can access any information. Then here also we can print the. Okay, here also. So here we are getting file pointer to the last location. We are printed the last location number also. Okay, we know exactly the location at the last line. Next, by using rewind, the file pointer is reassigned from the starting of the location. So if it is reassigned to the last starting of the location, then again have to find the location. What is the location? And we can print the location. That must be zero of the file, zero of the location. You can see here, initially the location is at 0. Okay, next total information is accessed. Next, after accessing all the information, the file pointer comes to the 18th location. Next, here we applied rewind here. So then after rewinding, we are again find such the file pointer location by using ftell. Okay, that is again pointing to the 0th location. So that is the advantage, and that is the way to access rewind and ftell. Rewind. Okay, if the file pointer location is currently is anywhere in the file, by using the rewind, that is pointing to the first line of the program, first record of the file. Okay, next ftell. Okay, it will returns the current location of the file pointer. It is the beginning position, middle position, or last position. Anywhere the file pointer is located, the current location will be given by the ftell. Rewind means the file pointer is located anywhere, that is shifted to the starting position of the file. So that is the ftell and rewind. Okay, here in these both functions we can find the random access. Okay, random Okay, the ftell give the current location. By using that ftell only, we can rewind or not, we can decide. Okay, if it is moved to, if you want to start listen from the starting of the file, use rewind. Anywhere of the file pointer is moved to the first line. So that is the usage of rewind. Okay, tomorrow we discuss about last function. Okay, that is the fseek function that contains more number of parameters are there. We can discuss tomorrow. Okay, today I'm going to close this session.